Let me share screen. Wait, you can all see my screen, right?
Yeah.
Okay, so as reminders, the second question is basically you have a class called movie, and it has 3 class variables: the title, the studio, and the rating, and all of these are strings. And the first part of the question asks us to write a constructor for the class movie, which takes in 3 arguments for the title, the studio, and the rating. And when we make a constructor, we want it to be public, and the constructor name is the same as the class name, which is movie. And it's taking in 3 arguments, so I just set them as string t, string s, and string r. And then in the constructor, I'm setting our class variable title to t, studio to s, and rating to r. In the second part of the question, it's asking pretty similar to the first part, except this time it doesn't take a rating argument in, so it's only taking in 2 arguments. So I still have string t and string s like before, but this time the rating is just set to PG, like what the question asks. And in part C, the question wants us to write a method getPG, which takes an array of movies and then returns a new array of movies, but these movies only have ratings of PG. So I'm actually using array list instead of arrays, but it's pretty similar if you're using arrays. And so first my method, it's public, and I called it getPG. It takes an argument of array list, and like the argument passing it, I'm calling it movie list. So the first thing we do in this method is that I'm making a new array list of movies called ans for answer. And right now this is just like an empty array list. And then in my for loop here, I'm looking at every movie M in the movie list I passed in. And now I'm going to check if the rating of M is PG. And because these class variables are private, I made like a method called getRating to just return the rating for me. So I do m.getRating to get the rating of the movie. And if this equals PG, then I'm adding this movie to my answer array. And then after my for loop finishes, I just return this answer array. In part D, I'm making an instance of the class movie with like these random stuff in it. So to do this, my variable name is this movie I'm making is mv1 or movie1, whatever. And so this is a movie, so I do movie mv1 equals new movie. And then I pass in the 3 arguments for title, which is Casino Royale, the studio Eon Productions, and the rating PG-13. And to test like the get PG method, I made like a few more movies and this array list test to test it on. And if I run this, it prints out all the movies that are PG, which is only the last movie I added. And because this one only takes 2 arguments, which means the default rating is PG. So this is the only one that's PG, since everything else is PG-13 or R or something. Does anyone have any questions?
No, ma'am.
All right.
Young, do you want to start on the presentation?
Okay. Let's see. How do I share? Oh, okay. Is it this? Okay, yeah. Okay, do you guys see my screen?
Yep.
Okay. Alright, I'll go ahead and start. Okay, so today is all about methods and recursion. So hopefully you guys already know what a method is. It's basically a segment of a code that you can call over and over again, which you give a special name. So there's something known as method overloading, which is when you can have the same method name, but it does different things but the thing is, Java can tell what method you're calling based on the input you give it. So for example, here, if I call my method and I pass in an int, Java knows it's not this my method because this one is asking for a float, and it knows it's not this one because that has two parameters. So it knows to apply the code that's in this method. So using this way, you can overload your methods. So that is sometimes useful in coding as well. And so here's an example. So here you have your main, and here it says that it was passed in 8 and 5, which are both ints. So that's why it went for this plus method right here, because it asks for ints. And also, it also returns an int, which matches up with the data type here. But this one here, you're passing in doubles, and Java knows that since these are doubles, not to call this plus method, it calls this one instead. But they do the same thing. They're adding numbers anyway, so I don't think it should matter. So it calls this plus method in this case, and that's how you get a 10.56 as an output. Okay, so what is recursion? So just like how a loop is a way to call on a certain section of the code over and over again, recursion is when a function calls itself. And it's similar to a loop where you have to follow the same section of the code again and again until you reach a certain condition. So a lot of complicated problems can be broken down into simpler problems if you use recursion that are easier to solve. So here's like an example. Here you see you're trying to calculate factorials. You could use a loop, but here we're going to show an example where you use recursion instead. So basically, you given a number, like for example here, you're trying to find 5 factorial. So what the number does is first it checks if you have reached 1 yet, which of course you haven't because you're still at 5. So it multiplies 5 with factorial of 5 minus 1. So what it does, it calls itself again. But this time, instead of entering 5, it enters 4, which is of course important because if it entered 5, it would like run forever. So it enters 4, and so you run this again, and when factorial 4 is just 4 times factorial 3, because you still haven't reached 1, and then it keeps doing this, so you end up with 5 times 4 times 3 times 2 until you end up at 1, in which case you trigger this case right here, which returns 1. It doesn't call itself again. And this is really important. Otherwise, you would never be able to leave this section of the code. It would be infinitely repeating, just like an infinite loop. So that's why that section is important. And this returns 120, just like we expected. So here's just like a step-by-step breakdown of what was going on. Okay. So basically, there's 2 parts of recursion, and I'll take this. Okay, let's see. Okay, I'll take this as an example. So basically, there's something called a base case, which I've already kind of went over. It helps you leave the recursive method once you reach like a certain case. So in this factorial method, the base case was when you reached 1, because that's what helped you leave the method. And then the second part is called the reduction step, which is basically what does the brunt of your work. It progressively makes your inputs smaller and smaller until you reach the base case. So for example, here the n times factorial n minus 1 is the reduction step, because here the factorial n minus 1 pushes us closer and closer to the base case, which is n equals 1, until we reach it. And that's the one that's actually doing the calculating factorial part. So here, yeah, it says the same thing. N is decreased by 1, so that's why it's getting reduced to the base case. So there's a special type of memory allocation for recursive methods, which is called a stack. So basically what happens is you'll see an example of this on the next slide, but if a function is called after it returns a value, like a recursive function, then it adds it to the stack to be done later. So when the base case is reached, the function goes through the stack and then takes out one by one the memory that was in the stack in a first in last out method. So for example here, so this is an example. You guys can go ahead and do this if you want, but I'll go through this one by one. So basically, it says if x is less than 1, you return nothing, and then else you do this. So if you put 3 in and try to see what it outputs, you'll see that it prints 3, then a space, and then it calls the method. So it will be it will call print fun2. But then this line, this system.out.print line, this thing is after the recursive call, so it doesn't. So this part is added to the stack. So what that means is this part right here is added to the stack. So what that means is basically it's kind of like a book stack where the thing that was added first is the last one you take out. So what will happen is that it will calculate print fun2, and when it does that, you'll see the same thing will happen again. Print fun2 will print at 2, then it will call print fun1, and then it will leave 2 to be printed later in the stack. So right now you have 2 things in the stack, print 3, and then on top of that there's print 2. And then you call print fun1. The base case still isn't triggered because 1 is not less than 1. So you print out 1, and then you do print fun0, and then you add like the step where you print 1 to the stack. So now you have 3 things in the stack. Finally, the base case gets triggered and you return nothing. So you have printed 3, you have printed 2, you printed 1, and you have 3 things in the stack left to do. So we'll go from top to bottom now. The thing at the top was print 1. So we'll print it, and then it will print 2, and then it will print 3. So here it explains what it does. So I'm not going to go over it again because I just went through it, but you'll see it prints 3 the first time around. This 3 is added to the stack. Then it prints 2. This 2 is added to the stack. Then it prints 1. Then 1 is added to the stack. Then it reaches the base case, and then it goes through the stack from first in, last out. So it prints this in reverse order of what they went in with. So you get this output right here. So sometimes these things can get a little bit complicated, so you want to keep track of what part of the recursive method you've already done. And that's pretty much it for this example. So you might be asking, why would you use recursion if loops always work anyway? It's because sometimes it's easier because it makes a simple section of the code. And that's sometimes really useful because maybe a loop can get really messy with how many things there are in there, and you might still miss some of the cases. So sometimes it provides a clean and simple way to write a code. And so you'll look at an example of how recursive methods can be more helpful. So now it's time for you guys to practice. All right, that's pretty much it.
Wait, did Sam share like the practice problems he made with you?
He did not, but I can look through the folder super quick. Okay, let's see. No, there's only the practice problem that Bella just did. Yeah, the recursive practice problem isn't on there.
Okay, I'm not sure if if he has the problem statement. I mean, like the practice problems. Like I asked him, but I don't know if he will respond. Actually, he's responding. Okay, I think he's about to send to me.
Okay.
Okay, so I think there actually is not a hackering, like we don't have a hackering prepared, because at least for the uses of recursion that you guys will probably be doing right now, nothing is that like testable with recursion. Like you can pretty much mostly just use loops and accomplish the same thing. With more advanced uses of recursion, it will be like where using loops will pretty much just be impossible. You would have to use recursion. But like since like it's not that worth it for us to like test you in like a hackering problem to use recursion, we just have like some practice problems. So I'm gonna share my screen to like present the practice problem. And I think we just have one practice problem this week. So basically like wait. Okay, so it's basically like let me pull up a sketchpad. Okay, so the function is basically um like given given like this, so basically we define a function f of x as f of x equals f of x minus 1 plus f of x over 2. Okay, where like this x over 2 is defined as integer division, so like you would truncate any remainder, and the base case is like f of 0 is 1. So basically just try to write a program that like creates this function, and then like try calling the function for different values of x to see if like the answer you get matches the answer that you get by hand. So like I'll give you guys a few minutes, and then afterward Mayan can show you like a solution to this. So yeah, I'm gonna screenshot this and then paste it in the chat. Okay, so the problem is in the chat now. Mayank, do you want to go to the solution to the problem?
Yeah, give me a sec. Okay, let's see. Share my screen. Okay. All right. So due to complicated reasons, I'm not at my usual setup, so I'm going to have to use this online IDE. But rest assured, I don't use this usually. Anyway, so I'll make this a bit bigger so you guys can see better. Anyway, so this is our function f. So it's a fairly simple problem to solve. Victor basically gave us the answer. Oops. Victor basically gives the answer in the question. So I'm calling the function f, and it accepts obviously an integer parameter. So if x is equal to 0, then we return 1 because that's just our base case. He just told us that f of 0 is just 1. So when we reach 0, we know that we can just return 1. Otherwise, we just return f of x minus 1 plus f of x over 2. So that was just like basically a definition where, so for example, if you want to find f of 3, then we'll do f of 2, which is x minus 1, plus f of 1, which is 3 divided by 2 is just 1 because you truncate. So this is just by going off the definition of the function. And so it's basically just this function right here. Like this is all there is to it. And if I run f of 3, then you'll see that I get 6. And if you go ahead and do it by hand, you'll see that you also get 6. There is a stack involved in here because this function, for example, f of 3, it will call f of x minus 1 eventually, but it will also store f of x over 2 in the stack. So you will have to apply the concepts of stack to solve this by hand. But either way, when you do that, you get f of you do get 6 by hand, and so does our code. So it seems to be working. I can try 5, and then we can see what we get. And we get 14, and I think this is what I calculated by hand as well. So this is my solution to the problem. All right, I think that's pretty much it. I'll let you guys take a screenshot of it if you guys want. Or actually, I'll just post it in the chat.